Alright. Hey everyone, welcome to hok'stutoring. Hope you're having a great day. Today we are doing question 11 from chapter 13C. So this is your inclined plane subtopic of your static dynamics chapter, and most of these questions are generally quite difficult to understand at the start. So I've made this video hopefully to help you guys have a greater understanding of inclined planes, especially with frictions and all your external forces. Aside of that, let's get into the question. Question 11. A particle slides from rest down a rough plane inclined at 60 degrees to the horizontal. So actually, whenever you're doing inclined plane question, the first thing you should always do is get a rough diagram, get a sketch of the diagram of these questions. So let's have a go. We have an inclined plane and it's inclined at 60 degrees to the horizontal, just like this. And you've got an object up here. So object on the inclined plane, and we know it is sliding down. Okay, so keyword, it is sliding down from rest. Right, so it is going down that way. So acceleration is going that direction. And let's keep reading the question. Given that the coefficient of friction, so there is friction here between the particle and the plane is 0.8, coefficient of friction, we call it mu, and that is 0.8. So friction, where would friction have to be? If your particle or if your object is sliding down the plane, friction always opposes the motion. Okay, so if it's sliding down, friction would have to be going up, so the other way. Okay, so that's what friction is. And the formula for friction, if you don't, and the formula, no, if you don't, no, is equals to mu, so your coefficient of friction multiplied by the reaction force. Okay, so mu multiplied by r. And now where is r? R is basically this force going up. It's always perpendicular to your plane. So whether it's horizontal, whether it's inclined, it's always perpendicular to it. Okay, now there's only a couple more forces that we're missing, and that is our weight force right here. Our weight force is always vertically downwards. Okay, so weight force is m multiplied by g. And whenever you draw weight forces on your inclined plane, you always have to draw this invisible triangle right here. Okay, because the weight force technically going down is bringing the object down, sliding down the plane, but then it's also helping, it's also but it's also got a vertical force but it's also got a perpendicular force to the plane. So that is 60. This angle right here is always the same. If you want to have a further understanding, or if you're still a bit lost, I highly recommend you check out the animated topic video I have on inclined planes. So check that out, and then you can maybe come back to this if you're still lost. But let's keep going through this question. So this is a 90-degree triangle. Okay, so the question is, find the speed of the particle after it has traveled 5 meters. So obviously it has to have traveled 5 meters downwards. What is the speed? So what is velocity? Okay, so in this case, we know that it starts from rest, so initial velocity is equal to 0. We also know that it would have traveled 5 meters down, so s equals to 5. And the other information that we're missing is actually acceleration. Whenever you deal with forces, there has to be an acceleration somewhere that you can find, right? So acceleration, you can find this. And then once we know all these pieces of information, this is a constant acceleration question, because acceleration in this case would always be constant. Then you can solve for v using your physics formula, okay? Your constant acceleration, one of those 4 or 5 formulas, right? So let's solve for acceleration first, and then after that we can solve for velocity. So in this case, if you want to solve for acceleration, remember Newton's second law of motion. If you want to get acceleration from force, it's net force equals to mass multiplied by acceleration. So let's get our net force first. In this case, we know the object is sliding down. There's only 2 forces affecting your object horizontally along the plane here, and there is the force going down the plane, and there's the friction force right here. Okay, so if you want to find what the force going down the plane is, that is equal to this force right here, the one that is, because an object slides down the plane due to gravity, but gravity is vertically straight down, and because it's on an inclined plane, then only part of the gravity force is moving the object horizontally down the plane. So not the whole mg, only part of it. And that is, if you want to find this part right here, so see that force right there going down horizontally to the plane, that is opposite of the 60 degrees, and we know mg is our magnitude, so it's mg multiplied by sine 60 degrees. Okay guys, mg multiplied by sine 60 degrees gives you that force going horizontally down the plane. And now of course we have to minus it by our friction force, because friction is going up the plane, so it's slowing down the object by a little bit. So how do you find friction? It's just the coefficient of friction, 0.8, multiplied by your reaction force. Now reaction force is over here. How would you find reaction force? We know going this way, your reaction force is perpendicular to your inclined plane, but then you also have the other force going down as well. They have to balance each other out, or else your object will go flying off the plane, or it'll go through the ground, okay? And that's not how it works. Your object just slides horizontally down the plane, and that's it. It's not going up, it's not going down, like through the ground at all, okay? So how would you find this other force right here? So this force, so once again, it comes from your invisible triangle. This is adjacent to the 60 degrees. So if you want to find that force, it will be mg, so your magnitude, mg multiplied by cos 60 degrees, okay? That's how you find your reaction force. So we know reaction force must balance out with the mg cos 60. That means reaction force must then also equals to mg cos 60 degrees, so that they balance out. So we just chuck that back in here, mg cos 60 degrees. And then we know that is equals to mass, which is, we don't know what the mass is, just have it as mass, multiplied by acceleration. Our acceleration, we also don't know, so we're just going to have it as a. Okay, now the first thing you can do is cancel out the mass, because you're dividing all sides, both sides by mass, and then they disappear, which is convenient. Then you're just left with some numbers and acceleration, which obviously means you cancel for acceleration. So guys, you chuck inside your calculator, g is 9.8, sine 60 degrees, that would be your root 3 on 2, and then blah blah blah. Put inside your calculator guys, and your acceleration in this case should be 4.567 meters per second square. So this is what your acceleration is, 4.567 meters per second square. Guys, once you've found your acceleration, it's very simple. You can easily find your velocity. Just take note that this acceleration is a constant. It's a number, see? It's not like 4.567 multiplied by t time or any of that. It's just a number. It's a constant. So we can use those for physics formula. Now, the one you want to use is the one that has v, u, a, and s. And that one is this one right here. V squared equals u squared plus 2as. So we just plug in the numbers. U squared is 0 squared. And 2 multiplied by a, which we just found, 4.567 multiplied by s, it would have traveled 5 meters. So if you solve for v squared, that is 45.67. But if you want to solve for v by itself, the velocity, the speed, then that is equals to 6.76 meters per second. There we go guys. That's how you answer this question. So basically, it's kinematics, but then to get acceleration, you have to use chapter 13, so your dynamics chapter, okay? And it's on an inclined plane. So hopefully, guys, this video helps you solve for this question. And if you did find it useful, please leave a like. That would be much appreciated. Aside from that, guys, thanks for watching, and I'll see you in the next video.